Now that we've got our crude benchmark in place, let's move to the second step of our exploration of TensorFlow on the Google Cloud. This time, we are going to make use of an estimator object. We will start with a really simple estimator. This is the linear regressor object. And as before, we will use this estimator in three steps. First, we will instantiate our estimator model object. Then we will train it by invoking the fit method on it. And finally, we will go ahead and use this trained model for prediction by calling the predict method on our trained model. By now, we've worked a fair deal with estimators in TensorFlow. So hopefully the way in which these three methods have to be invoked will come as no surprise to us. While instantiating our estimator model, we will need to pass in a function. This function will need to return a list of all of the features that are going to be used by that model. In the code that we are about to examine, this will be accomplished using a function called makeFeatureCalls. This will return a list. Every element of that list will be an object of type tflearn.layers.realValued column. Once again, this ought to be a fairly familiar type of object to us. That does it for the instantiation. The next step will involve actually training the model. For this, we will need to invoke the fit method. The fit method always needs to be passed in a function. That function, which is the input function, serves as a bridge between the estimator and all of the feature and label data. As before, this function will have a very characteristic return value. The return value needs to be a pair. The first element in the pair will be a dictionary of all of the features. The second value in that pair is going to be a list of all the labels. The features dictionary has as the keys all of the feature names, and as the values all of the corresponding feature values. These are tensors. And the labels, these are simply a list of all of the y values, that is, the dependent variables which need to be predicted. And in this way, the input function that we pass into the training method, that's the fit method, always needs to return a pair, the first element of which is a dictionary, the second element of which is a list of labels. Once we do have a trained model, all that remains is for us to actually predict new values of x using this trained model. This we will do using the .predict method of our model object. This predict method also needs to take in a function object. This function object will need to return only a dictionary of the features. Clearly, when we are using our model for prediction, we do not have the labels, and that's why it would not make sense for this input function to return labels as well. So while predicting, we simply pass in a function which is going to return a dictionary of all of the features. So without further ado, let's plunge into the TensorFlow portion of this demo. We now browse to the machine learning directory. This is contained within the code that we cloned from the Git repository. Within the folder called TensorFlow, there are A, B, C, and D. That is 4 IPython notebooks. Let's very quickly look at the first of these. This is a gentle introduction to TensorFlow. At this point in this course, we don't really require this. Let's move on to the second. In the second IPython notebook, we are actually going to make use of tflearn and create a linear regressor estimator object. So let's open up this notebook and see what it's all about. As usual, it begins with a bunch of import statements. These are all ones which we have encountered before. Let's go ahead and run this. We are working with version 1.2.1 of TensorFlow. Next, let's set up a few helper variables which contain the names of our columns, the names of our target column, and the features. Then we can read in the data frames for the training and the validation data. We just make use of the read CSV method from pandas. Notice here that we are reading in the in-memory files which we just created a few moments ago. Next is the make input function method. This is something which we just spoke about. This will return the input function. That input function needs to return a pair. The first element in the pair needs to be a dictionary of all the features. The second element in the pair needs to consist of the labels. Next up is the make feature calls method. This simply returns a list of real valued columns. This is something that we will need while instantiating our estimator object. We now have set up the input function. Let's go ahead and instantiate our estimator object. As discussed, we are going to make use of the tf.contrib.learn linear regressor object. We need to specify the make feature calls function as well as an output directory where we would like to write the saved model at the end of this process. We then go ahead and train this model using the fit method. Here we need to pass in the make input function method with only the training data. We go ahead and build this model, and then we run this model on our benchmark. That was the validation benchmark. So we invoke the .evaluate method, and we also pass in the same input function as we did for the training. We print the RMSE, that is the square root of the loss metric. And remember that the value we had obtained with just our crude benchmark was 8.03. So we are quite disappointed here to see that the RMSE we now get is 9.06. That is substantially higher than we obtained with our really crude average per kilometer rate. That's fine. We are going to refine this model. Before we do that, let's go ahead and use this model for some prediction. So here we make use of the .predict method on our linear regressor object. There are a couple of interesting points here worth noting. The first is that we actually deserialize or read the saved model. This saved model is from the location which we just wrote a moment ago. This is then written to a variable called model. We invoke the .predict method on this model, which was the deserialized version of the one we trained a moment ago. The other interesting point worth noting here is that we actually make use of the validation data. So we pass in our validation data frame into the make input function and then get the first 5 data points from that validation data frame and pass those in to our model for prediction. And when we do so, we get a sense of why this model performs so poorly. We find that all of the predictions are very close to each other. They are all just about 11.2. Basically, our model is predicting around $11 no matter what the values of the input X variables. This model is clearly not good enough. Let's try something a little more complicated. Let's make use of a DNN regressor instead of a simple linear regressor. The DNN regressor will build a more complex neural network, a deep neural network. And for this, we will need to specify the number of layers. We choose 3, as well as the number of neurons within each layer. Here we specify 32, 8, and 2. Other than this change in the topology of the neural network, very little changes in our code. That's because the DNN regressor, just like the linear regressor, is a high-level estimator object. Virtually nothing else in the code needs to change other than that one object instantiation. We go ahead and rerun our benchmarking code, and once again we find that our RMSE on the validation dataset is still very poor. It's at 13.81, which is still substantially worse than the 8.03 which we obtained with our crude distance-based measure. Clearly, we are going to have to do something different in order to make machine learning work for us here.